सर आवाज येत नाही.
नाहीये. आता येतोय का? प्लीज टेल मी, आवाज येतोय आता?
सर आता येतोय, आता यायलाय.
Okay. So we have just discussing the things related to the stability factor. See, when we have to use the transistor for different application, right? So transistor used for different application. In that case, stability is the important issue, right? When stability is not good for your device, in that case, what happen? The effect of the transistor is not acceptable, right? Because stability is not with respect to your device indicate that performance of a transistor with respect to time it changes, right? So this is not acceptable. So that's why we have to be requirement of the stability factor analysis for the different type of the configuration. So that we have to be seen the stability factor analysis for fixed biasing. So we have to be analyze this circuit and we have to be use the formula of this same. See, as we have to be analyze this formula, S is equal to 1 plus beta divided by 1 minus beta into delta IB by delta IC. This is the formula for the stability factor. We have analyzed this circuit and after all analysis, we got the equation. We have just got that equation with respect to IB by IC, which should be put it over here. And we got the particular value of the stability factor, right? Now see, this is the fixed biasing configuration. So fixed biasing is the configuration in which we have to use the, this is RB. RB is the fixed type of the resistance for this type of the configuration to provide the base current, right? Base current providation, we have to use this RB, that is fixed type of the resistance with respect to this type of the configuration. So see, for that purpose, for the analysis purpose, we have to be apply the KVL at input side, output side only. See, when we have applied the KVL at input side, in that case, your equation is started with this plus VCC and end up with this VB, right? So plus VCC minus of IB into RB minus of VB. This is the equation with respect to input, right? This is the equation. VCC minus of IB into RB minus of VB, right? So what we have to do? We have requirement of three thing calculation: IB, IC, and the VC. So in this equation, IB is here. So we have to be taking on another side this minus IB into RB. So minus IB into RB going on another side as IB into RB. So here VCC minus VB, VCC minus VB, right? So we requirement of the only IB equal to, so that IB taken as here, RB going on this side. So it is a multiplying going on another side as a divided. So VCC minus VB divided by RB. See, VCC minus VB divided by RB. This is now equal to the IB, right? So we have to be calculate the, we know that another factor with respect to the stability is that it is the ratio of the rate of change of collector current with respect to rate of change of collector leakage current, right? That is IC divided by IC divided by ICO, right? That's why we have to be differentiate the same with respect to DIC, right? So differentiate with respect to IC. So D differentiate of this with respect to IC. So it is nothing but a DIB by DIC, right? DIB by DIC. So differentiating all this with respect to 1, right? So D by, here is not any term because this is in a bracket. So D by DIC into bracket VCC minus VB of RB coming with respect to here. So DIB by DIC equal to D by DIC into bracket VCC minus VB divided by RB. This is the equation which should be coming with respect to this, right? So we know that DIB by DIC equal to 0, phi t 0. See, DI by DIC indicate the rate of change of, right? D indicate rate of change of. See, whatever the current provided by this indicate that this resistance, the value of this resistance, I'm already told you is fixed. So whatever the current flow provided by this type of the resistance is also fixed. So it doesn't have rate of change. So it should be 0. No rate of change indicate that DIB by DIC equal to 0. हा, आवाज ऐकू येत नाही का? प्लीज रिप्लाय द्या. आवाज ऐकू येतोय?
येतोय सर.
ओके. सो वी नो दॅट रेट ऑफ चेंज याचा अर्थ काय असतो माहिती आहे का? याच्यामध्ये चेंज होतोय का नाही. जर चेंज होत नसला तर तो 0 असतो, लक्षात घ्या. सो हिअर डझंट हॅव एनी चेंज. सो why it is not changed? Because RB value is fixed. So that DIB by DIC value equal to 0. So dIB by dIC equal to 0 here, 0, right? So the equation coming with respect to is here is dIB by dIC which equal to 0. So delta IB by delta IC which is equal to 0. This term we have to be used here in equation. So we know that this equation is nothing but a whatever the equation coming for stability factor, right? This is equal to 1 plus beta divided by 1 minus beta into delta IB by delta IC. See the equation. See, S is equal to 1 plus beta divided by 1 minus beta to delta IB by delta IC. So 1 plus beta as it is 1 minus beta delta IB by delta IC. We know that it is a 0. So 1 plus beta 1 minus beta into 0, right? So beta into 0 indicate that 0, 1 minus 0 indicate that 1. So 1 plus beta divided by 1 indicate that 1 plus beta only. So stability factor for the this type of configuration indicate that fixed bias configuration is nothing but a S is equal to 1 plus beta, right? हे आपलं लास्टच्या वेळेस झालेलं आहे, लक्षात आलंय का? प्लीज रिप्लाय द्या. लास्ट टाइमला झालेलं आहे, आपण न्यू पार्ट घेणार होता आता. लक्षात आलंय ना? रिप्लाय द्या. ऐश्वर्या गायकवाड, लक्षात आलंय का? लक्षात आलंय का? रिप्लाय द्या. Yes or no?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Now see, we have to be analyze the different type of configuration. We have seen the three type of configuration with respect to us. That is a one is your fixed bias, other is collector to base bias, and third is voltage divider bias. So for particular configuration, we have to be seen the stability factor analysis. We have to be analyze this configuration by applying the KVL at input and output side and taking the equation with respect to IB and IC and the VC, and that equation we have to be put out the value of the stability factor. See, this is the collector to base biasing. So collector to base biasing, this circuit we have applying the KVL at the input side. This is nothing but input side. See, this is the input side. See here, this current is not only the collector current. Why it is? Because base feedback is taking over here, means current is taking from your base towards the collector. That's why the current flowing through this is not only collector, it is a collector to base, collector plus base current, right? So apply KVL to the input side. Input side KVL indicate that this is your input side, right? So this indicate that this as well as this going towards the here. So started with the plus VCC. So plus VCC, this going or out of this, so minus plus VCC minus of IC plus IB into RC. See, minus of IC plus IB into RC. Then here minus of IB into RB, right? Minus of IB into RB. Then minus of VB, right? Because it is taking out of the junction, right? Minus. So all of the equation is nothing but a plus VCC minus of IC plus IB into RC minus of IB into RB minus of VB. This is the equation with respect to input side, right? So this equation is here plus VCC minus of, we have separated out this thing, right? Plus VCC minus IC into RC minus IB into RC, separate out, right? Here is a plus, but we have written as a minus. Why? Because minus of IC here and minus of IB. That's why it is a minus of IC into RC minus of IB into RC, right? Minus of IB into RB minus of VB, which is equal to 0, right? So plus VCC minus of IC. Now see, multiply by this thing separately. So IC into RC, then minus of IB into RC. This is the things, right? So your equation is nothing but a plus VCC minus of IC into RC minus of IB into RC minus of IB into RB minus of VB, which is equal to 0. Now see, we have separated out two things, which are that plus VCC and minus VB, which taking on one side, plus VCC minus VB, right? Plus VCC minus VB, this thing going another side. So it should be going as a minus as a plus. Plus VCC minus VB, which is equal to plus IC into RC minus of IB into RC, then here minus of this should be going as a minus, it should be taking as a plus IB into RB, and this as a plus, so plus IC into RC, right? These three things, see, plus VCC minus VB only taking as a here, this term going on another side, so minus going another side as a plus IC into RC, then this minus going another side as a plus IB into RC. Now see, this minus going another side, it should be as plus IB into RB, right? So this term coming with respect to us. See, now see, VCC minus VB. Now see, this is the same IC into RC. We have taking out. See here, IB is common. We have taking IB as a common here. See, VCC minus VB as it is equal to IC into RC, taking IB as a common. So IB into bracket of RB plus RC, right? So this is the equation. In this equation, we have to be differentiate with respect to IC. Why? Because to calculation of the IC, so stability factor, it is the ratio of the collector current to the collector leakage current. So that's why we have to be differentiating with respect to IC, right? So this is taking in a bracket. So D by D here is not any element. That's why we're taking as a D by DIC into bracket VCC minus VB, which is equal to IC into RC. See, RC taking as a common term. That's why it is taking as a separate RC. IC is the current. So DIC by DIC, right? DIC by DIC. D for this IC and DIC for the differentiation, right? Plus RB plus RC taking as a common term. And here we have to be use the D, DIB by DIC. See here, DIB by DIC. Okay, so your equation whatever coming is, we know that this term is not changing with respect to term, कारण VCC जे आपण अप्लाय करतो ना 10 व्होल्ट किंवा 12 व्होल्ट असेल ते फिक्स असतं. बेस टू मीटर व्होल्टेज 0.7 व्होल्ट फिक्स असतं, ज्याच्यामध्ये कुठलाही चेंज नसणार आहे, त्यामुळे ती व्हॅल्यू 0 असणार आहे. बरोबर, डी बाय डीआयसी व्हॅल्यू 0, ही 0 असल्यामुळे ओके 0 असणार आहे. त्यानंतर IC into DIC by DIC, it is a 1. DIC by DIC indicate that 1. So 0 equal to RC into 1 plus RB plus RC, RB plus RB, DIB by DIC. It is as it is. So your equation is, this is a 0, which is equal to RC into 1 plus RB plus RC into DIB by DIC. This is the thing, right? So we have taking this RC another side. So plus RC going another side as a minus RC. So minus RC equal to RB plus RC into DIB by DIC, right? So we have taking out DIB on one side and this other thing on another side. So DIB by DIC equal to minus RC divided by RB plus RC, right? This term going another side as a divided, multiply divided. So minus RC divided by RB plus RC. This is the thing coming with respect to this equation. Okay, and now see, this is the value for delta V by delta C. We have one of the equation of the stability factor, that is S is equal to 1 plus beta divided by 1 minus beta into DIB by DIC. We have put out only this value DIB by DIC, okay, here, right? So 1 plus beta divided by 1 minus beta DIB by DIC indicate that RC divided by RB plus RC. So see, RC divided by RB plus RC, right? Here is a minus term. Why it is minus? Because plus RC going here as a minus. So here 1 plus beta divided by 1 minus beta into delta B by delta C is nothing but a minus RC divided by RB plus RC. This is the term, right? So 1 plus beta divided by this minus and this minus taking as a plus. So 1 plus beta into minus RC into RC divided by RB plus RC. This is the term coming with respect to stability factor. So stability factor for the collector to base bias circuit is nothing but a S is equal to 1 plus beta divided by 1 plus beta into bracket of RC divided by RB plus RC. Okay, now हे लक्षात आलंय का? एक लक्षात घ्या, नोट्स मध्ये जे आहे ना ते डिटेल एकदा बघितल्याशिवाय लक्षात येणार नाही. त्यामुळे तुम्ही हे पार्ट झाला ना, निदान नोट्स किंवा तुम्ही टीचिंग डायरी लक्षात घ्या, टीचिंग डायरीला रेकॉर्ड असते, आपल्या टीचिंग डायरीला, त्याच्यावर जाऊन तुम्ही ते पाहू शकता. म्हणजे एकदा, कारण एकदा सांगितलेलं लक्षात येत नसते, त्यामुळे पाहत जावा. ओके, हे लक्षात आलंय का? प्लीज रिप्लाय द्या.
Yes, sir.
Okay. Now we have seen the one of the important factor, that is stability factor for voltage divided by 6. See, as we have already seen the three type of configuration, that is collector to base bias, that is voltage divider bias, and the second configuration as a collector to base bias, and third is fixed bias, right? These are the three configuration we have seen already, but here we have seen the stability factor for the particular configuration, right? So we have seen the stability factor for voltage divider biasing here. Now see, this is the voltage divider configuration of your calculation of the stability factor, right? We have to be calculate the stability factor of this type of the analysis. If we have seen this calculation, in that case what happened, analysis of this configuration is not so simple, right? It is a hard. That's why this type of the configuration reduced by applying the Thevenin's theorem, right? So by applying the Thevenin's theorem, this type of the two resistors indicate that the voltage across this is a V1, voltage across this is considered as a V2. So we have analyzed the circuit such a way that V1 and V2 we are taking as a one voltage by applying the Thevenin. Did you getting my voice? Please reply. Did you getting my voice? Please reply.
सर वाईट येत नाहीये.
Okay. आता येतोय का? आता येतोय का आवाज? आता आवाज येतोय का? रिप्लाय द्या. आवाज येतोय का आता? प्लीज रिप्लाय करा. आवाज येतोय का?
येतोय सर.
Yes, sir.
ओके. इंटरनेट गेलं होतं. ओके.
Oh, sir.
Okay, we have seen the stability factor for voltage divider biasing method, right? So voltage divider biasing method is the method which should be used for the different application of your transistor many more times, right? Because it has some of the advantages with respect to designing of the circuit, right? So this is the basically voltage divider biasing configuration of your transistor, right? So analysis of this type of configuration is not simple. That's why we have to be analyze the this type of circuit with by applying the Thevenin's theorem to this type of the configuration, right? So that this R1 and R2, this resistance is equivalent resistance formed as a RTH, right? And the voltage coming across here, voltage coming across R1 is a V1, and voltage coming across R2 it is a V2. So V1 and V2 is taking as a Thevenin's voltage, VTH, right? They should be combining each other and taking as a VTH voltage. R1 and R2 resistance taking as a combined resistance and taking as a RTH resistance. All other things are the same with respect to this type of the configuration. This should be done only for the purpose of analysis needed, right? So see, same in this circuit also we have to be applied the KVL, right? KVL to the applied with respect to input as well as the output. We have calculating the value. आवाज येतोय का? प्लीज रिप्लाय द्या. आवाज येतोय? प्लीज गिव्ह मी रिप्लाय.
ब्रेक होतोय सर.
आता येतोय क्लिअर?
Oh,
Hello?
sir.
Okay. So we have seen this type of the configuration by converting this equation into by applying the Thevenin's theorem. This is the equation. For that equation, we have applied the KVL to the input side. Input side indicate that this point plus VCC, ICRC, and this way, this is called as input side, right? This is called as input side. So that we are applying the KVL to the input side. This is the thing, right? See, I'm telling wrong, such wrong. See, input side indicate that started with VTH and going towards the IBRTH, going to the VB, then RE. This is nothing but a input side, okay? And this is nothing but ICRC, VCN, INRE. This is output side, right? So for that purpose, we are applying the QL to the input side, right? So it is nothing but a apply QL at input side. So plus VTH minus of IB into R. See, this is the figure. In that figure, we have to be apply the QL at input side, right? So applying QL at input side indicate that VTH, start up with VTH minus of IB into RTH minus of VB, because second point is considered as a minus. So plus VTH plus minus. So it is nothing but a plus VTH minus of IB into RTH minus of VB, minus of this way. Current flowing through this is I, so minus of I into RE, which is equal to 0. So your equation is VTH minus of IB into RTH minus of VB minus of I into RE, which is equal to 0. This is the equation coming with respect to the same, right? Now see, in that equation, we are taking out two things separate, VTH minus VB, right? VTH minus VB. Now all other thing going on another side, it should be as a positive. So VTH minus VB, which is equal to IB into RTH. This is a plus IB into RTH minus of I into RE, going on another side as a plus I into RE. So your equation is VTH minus VB, same plus IB into RTH plus I into RE. This is the equation. Now see, VTH minus VB, which is equal to IB into RTH. Now see, I into RE, right? So I into RE indicate that, see, I into RE indicate that this is nothing but a I. So I is nothing but a, see, 1 minute. So for that equation, see, for that equation, IE is taking as a IB plus IC, because here whatever the current flowing through the device is IE plus RE, sorry, IB plus IC, right? So your equation is IB into RTH plus this IB multiplied by RE, separate IB into RE, IC into RE, separate out this thing. So your equation is VTH minus VB, which is equal to IB into RTH, I into RE, it should be taking as a separate out. So I is nothing but a emitter current. We know that equation, I equal to IB plus IC. So for I, we have to be written as IB plus IC here. So I is nothing but IB plus IC RE as it is, right? So your equation is IB into RTH plus IB into RE and IC into RE. This is the equation, right? So your equation is nothing but a RTH plus RE, right? This is, we have taken IB as a common term, right? Common term. So IB should be common. So RTH plus RE, RTH plus RE plus did you getting my voice? Please reply. माझा आवाज येतोय का?
सर ब्रेक होते खूप.
आता सांगा, आता येतोय का? आवाज येतोय का सांगा, आता येतोय का?
ब्रेक होतोय सर.
ओके. आता येतोय आवाज? आता आवाज येतो?
नो सर ब्रेकच होते अजून पण.
आता येतोय? आता आवाज क्लिअर येतोय का? हॅलो.
नो सर येत नाहीये.
आता सांग, आवाज येतोय का? आता येतोय क्लिअर? आवाज क्लिअर येतोय का आता? नम्रता घोडके, आवाज येतोय का? प्लीज टेल मी. आवाज येतोय का आता? प्राची भोसले, आवाज येतोय का?
नो सर ब्रेक होतय.
ओके. आता बोला, येतोय? ब्रेकच होत आणखीन. आवाज ब्रेकच होतोय की येतोय अजून? प्लीज रिप्लाय द्या.
येतोय सर.
Okay. So in this equation we have applied the KVL at two sides, that is input side and output side. Now see here we have applied the KVL at input side. It indicates that VTH minus of IB into RTH minus of VB minus of current flowing through this is IE. So it is IE into RE. This is the equation coming with respect to us. So VTH minus VB, this taking as a one side and this minus is going on another side. It is a plus. So IB into RTH and the plus I into RE coming across here. We know that I equal to IC plus IB. So for that IE we have to be taken as a IC plus IB. So VTH minus VB, which is equal to IB into RTH plus for that IE we have taking out IC plus IB.
सर वाइस ब्रेक होतोय.
आता पण ब्रेकच होतोय का? आता पण व्हॉइस ब्रेकच होतोय का?
तर
हो सर.
क्लिअर येते आणि थोड्या वेळाने लगेच ब्रेक होतोय.
ओके. इंटरनेटचा इश्यू. आता येतोय का क्लिअर? पण सध्याला ज्यावेळेस ब्रेक केला त्यावेळेस लगेच सांगा तुम्ही. आता येतोय क्लिअर? प्लीज
नो
रिप्लाय.
सर येत नाहीये. नाही येत.
आता येत असेल चांगलं, मला वाटतं रेंज आली भरपूर. आवाज येतोय का आता? आता हॅलो, आता येतोय का आवाज? ओके, थोडं जस्ट ब्रेक होईल त्यावेळेस सांगा मला, चालू करतोय मी. हा पहा, करंट flowing through this is nothing but a IE into RE. It should be taking as IB plus IC. So IB into RTH, this IE into RE, it should be IB plus IC into RE. This should be value because we know that I equal to IB plus IC, right? So IB into RTH as it is. So IB multiplied by RE, it is nothing but IB into RE. IC multiplied by RE, it is nothing but IC into RE. So your equation is nothing but a this is nothing but we have taking for that IB these two thing taking in a bracket and IB taking as a common. So IB common RTH plus RE. So IB is common RTH plus RE. This is the equation with respect to this thing. So IC into RE as it is, right? Now see, for the calculation of the stability factor, we have differentiating this equation with respect to IC. So for that equation, this is nothing but a VTH minus VB, which is equal to RTH plus RE into IB plus IC into RE. So it is nothing but a D by DIC into bracket of VTH minus VB, C, equal to RTH into RE, C, RTH into RE. Now CIB, for that we have written as a DIB by DIC, C, DIB by DIC plus this is RE taking as a constant outside RC. Now C for IC, DIC by DIC, DIC by DIC. For that IC, we are taking as a DIC by DIC. Okay. So your equation C, we know that this value VTH minus VB is not changing at all. So for that factor D by DIC is equal to 0 because this is not changing with respect to time. So it is a 0. Now C RTH minus RE DIB by DIC. See as it is. This is as it is. Now see for this configuration. For this configuration, DIC by DIC, it is nothing but a same value, that's why 1. So your equation contain RTH into RE DIB by DIC plus RE only. See, RTH plus RE into DIB by DIC plus RE. This is the value for purpose of your equation. Now this plus RE going on another side, it is a minus RE. So RTH plus RE DIB by DIC. Now see, DIB by DIC taking on one side, this taking on another side. So it is nothing but a minus RE divided by this multiply going on another side as a divided. So minus RE divided by RTH plus RE. This is the equation, right? So coming with respect to us. So DIB by DIC value, this should be taking in a following equation. So S is equal to 1 plus beta divided by 1 minus beta into bracket of delta IB by delta IC. So in this equation, 1 plus beta as it is, right? 1 plus beta as it is. So 1 minus beta, see 1 minus beta, I'm telling you again, 1 minus beta, and this value is nothing but a RE divided by RTH plus RE, RE divided by RTH plus RE, but this value is a minus. So this minus multiplied by this minus indicate that plus, that's why 1 plus beta, here is a plus is coming, right? Not a minus, because minus into multiply by minus, it is a plus. So 1 plus beta into RE divided by RTH plus RE. This is the value for stability factor for this voltage divider biasing, right? Right. So see, I'm telling you again this because there are different time interrupt coming. See, stability factor for voltage divider biasing, we will see. This is the configuration. It is called as voltage divider biasing, right? So analysis for this type of the configuration is not simple. It is hard. So that's why this type of the configuration is taking as a Thevenin's theorem, applying the Thevenin's theorem and shorten this, and we have to be apply the KVL for this circuit, right? So voltage coming across R1, it is called as Phi1. Voltage coming across R2, it is called as Phi2. So this Phi1 and Phi2 taking as a one term, and this should be called as VTH. And this resistance R1 and R2 taking as a one resistance, so it is called as RTH. And after all doing this, we have to be drawing the all other circuits same way. right? This is the circuit, equivalent circuit of this voltage divider biasing, right? We are applying the KVL for this type of configuration, because when we are applying the KVL to this type of configuration, it complexity increases, right? So apply KVL to the input side. So in input side indicate that started with VTH and end up with the RE. So it is nothing but a plus VTH minus of IB into RTH minus of VB minus of I into RE. This is the equation coming with respect to this equation, right? So VTH and minus VB taking as one side, and this minus going on another side, it is nothing but IB into RTH, and this minus as a plus I into RE, right? So VTH minus VB, which is equal to IB into RTH, and this IE is nothing but one of the equation for IE, I equal to IC plus IB. So for that IE we have to be written as a IC plus IB into multiply by RE. So IB plus IC into multiply RE. So your equation is VTH minus VB, which is equal to IB into RTH plus IB multiply by RE, IB into RE, IC multiply RE, it is a IC RE. This is the equation, right? So we have taken these two equations, RTH, IB common. So we have taken IB as a common term. So RTH plus RE, IB RTH plus RE. So IC plus IC into RE. This is the equation. Now see, differentiating about this equation with respect to IC, because when we have to be calculate the stability factor, in that case we have requirement of the differentiating all of the thing with respect to IC, so that d by dIC, because here d by dIC for this, because this equation is nothing but a VTH minus VB equal to RTH plus RE into IB plus IC into RE, right? So differentiating with respect to IC is indicate that d by dIC into bracket of VTH minus VB, which is equal to this is the things. So RTH plus RE, for that IB we have to use DIB by DIC, right? DIB by DIC plus RE taking as a constant term, and this IC DIC by DIC, right? So DIC by DIC is nothing but a 1. So all other things means RTH plus RE into DIB by DIC plus RE is came across here. See, so we know that this is a 0. Why it is 0? Because the value of the VTH minus VB, it is a fixed. That's why no change. That's why it is a 0. And RTH plus RE DIB by DIC, it is also constant, right? Plus this should be taking as 1. So your equation is, this is a 0 equal to RTH plus RE into DIB by DIC plus RE. See, plus RE. This is the equation. Now see, this plus RE going on another side, it should be taking as a minus RE. So RTH plus RE into DIB by DIC. Okay, so we have to be separate out the DIB by DIC on one side. So DIB by DIC, which is equal to minus RE is on another side. So this multiply going on another side as a divided. So minus RE divided by RTH plus RE. So the stability factor is given by, we know that this is equal to 1 plus beta divided by 1 minus beta into delta IB by delta IC. So 1 plus beta as it is. Now see, 1 minus, see here, I'm again tell you 1 minus here, but whatever the value of this is minus RE divided by RTH plus RE. So minus minus plus. So it is a 1 plus beta into RE divided by RTH plus RE. Right? This is the equation for purpose of the stability factor analysis. Okay. Okay. There are times. To this time we have to be cover this type of the circuit. See, AC and DC equivalent circuit of the common emitter amplifier. See, above figure shows that the common emitter amplifier. Why it is called as common emitter? Because see, we know that this is the transistor. This is a collector, this is your base, and this is your emitter terminal, right? Common emitter indicate that this emitter terminal is in between your input as well as output, right? This emitter terminal, that's why it is called as common emitter type of the configuration. Now see, we have to be seen the AC and DC analysis of this configuration indicate that there are some of the condition to analysis the circuit with respect to an AC and DC. तर लक्षात घ्या ज्यावेळेस आपल्याला सर्किट एखादा ऍप्लिकेशन साठी यूज करायचं असतं त्यावेळेस त्याची एसी किंवा डीसी अनालिसिस आपल्याला बऱ्याच केसेस मध्ये करावं लागते. त्यासाठी एसी आणि डीसी अनालिसिस कशी करायची असते ते आपण इथं पाहणार आहोत. पहा जर एसी अनालिसिस करायचं असेल तर याच्यातलं काय करायचं सांगतो. सगळे जे डीसी सोर्स आहेत ना ते झिरो घ्यायचं म्हणजेच फिन काय येतं म्हणजेच हे जे व्होल्टेज इनपुट अप्लाय केलेलं आहे लक्षात घ्या. जर आपल्याला डीसी अनालिसिस करायची आवाज येतोय माझा प्लीज रिप्लाय द्या. आवाज येतोय माझा
सर वॉइस इश्यू आहे.
चालेल आपण नेक्स्ट पार्ट शिकवत नाही मी अटेंडन्स द्या मला. ओके जर माझा नाही आवाज आला तर तुम्ही याच्यावर चॅट बॉक्स मध्ये सांगा तुमचं. ओके रोल नंबर 1 रोल नंबर 1 प्रेझेंट और नॉट. Rule number 1. Rule number 2. Absent का 3. Rule number 3. Rule number 4.
Present.
Okay. Five.
Present.
6.
Yes, sir.
7. 8.
Present.
9.
प्रेझेंट सर.
10.
Present, sir.
11. 12.
Present, sir.
13.
प्रेझेंट सर.
14.
Present, sir.
15.
Present, sir.
16.
Present, sir.
17. 18. 19.
18, sir, 18.
Okay. 19. 20.
प्रेझेंट सर.
दोघ जण आहेत काय? Who is 20? रोल नंबर 20.
20 प्रेझेंट सर.
ओके. परत एकदा रोल नंबर 20.
20 प्रेझेंट सर.
ओके. 21. 22.
Yes, sir.
23.
Yes, sir.
24.
Yes, sir.
25.
Yes, sir.
26. 27. 28.
Present, sir.
29. 30.
Yes, sir.
Roll number 30.
Yes, sir.
31. 32.
Present, sir.
33.
Present, sir.
34. 35.
Present, sir.
36. 37. 38. ओके ऑप्शन नंबर सांगतो 1 2 3 6 7 11 17 19 21 26 27
सर
20
6 प्रेझेंट आहे
27 29 31 34 36 37 38. ओके 6. अजून कोण? 1 2 3 7 11 17 19 21 26 27 29 31 34 36 37 38. ओके यापेक्षा वेगळं कोण आहे का अजून प्रेझेंट? ओके टेस्ट
ओके सर.
किती? 33 आहेच की प्रेझेंट. बरं याच्यावरची टेस्ट झालं घेतली चालेल लगेच. MCQ टेस्ट असेल चालेल ना? चॅप्टर
Yes,
झालं
sir.
की लगेच घेऊन टाकू आपण. एक लक्षात घ्यायचा 1 मिनिट.